All right, lesson 9, function models and applications. So here we're going to draw scatter plots to find a trend line equation, identify an appropriate function type to construct the function model given a scenario, describe underlying assumptions about a model for a given scenario, construct a linear, polynomial, or piecewise defined function to model a scenario, construct a rational function model based on a context, apply a function model to answer questions about a data set, and use technology to find and compare regression equations. All right, so function models and applications. So it tells us here that this lesson will help us to construct linear, polynomial, or piecewise defined function models and applications given a real-world scenario. So in example 1 here, finding a trend line. It says an antique dealer visited an auction house and recorded an estimated selling price of 6 different antique chests. Then he checked the actual selling price after the auction ended. The data points, which are the estimate, the actual, show the results where each number is in thousands of dollars. A wants us to draw a scatter plot and the trend line, and then B wants us to write the equation of the line. So first thing we're going to do is we're going to draw our scatter plot. So we're just going to plot those values. So I'm going to go plot the point 12.511. And then 8 and 9.5. 10.5 and 12, 5 and 3.9, 9, 10, and 7, 6.5. All right, so there's my scatter plot, and then it wants me to draw the trend line. So that's the line that's going to kind of go through the middle of all these points. And so somewhere in here is going to be my trend line. So that's A. B says to write the equation of the line. So for B, we know that that line is a straight line, so it's going to follow slope-intercept form. And so first thing I need to do is find my slope. And so remember, your slope is just the y2 minus y1 over x2 minus x1. And so I just need to pick two of these ordered pairs. So I'm going to pick the first one, and let's pick one in the middle there. All right, so I'm going to subtract my y's over, subtract my x's. When I do this, I get approximately, 7.1 over 7.5, which is approximately 0.95. All right, and then there's a bunch of different ways I could use point slope form, or I can just pick an ordered pair here. It doesn't matter which one. So I'm going to use the 5 and the 3.9. So this is an x and a y, and I know my slope is approximately 0.95, and I can just plug that into that y equals mx plus b, solve for b, and then plug m and b back into the equation. So we're going to have our y equals m times our x, which is 5 plus b. And so I'm going to work that out. I'm out of room here, so I'm just going to put my b. So I'm going to multiply the 0.95 times the 5 and then subtract that from the 3.9, and I'll get b is equal to negative 0.85. Now I know my m and my b, so I can write my equation. So y equals m, so 0.95x plus b, so minus 0.85. And so there's the equation of my line. And we're just going to put a little hat on top of that, y hat. That way it's just an estimation. It's not the exact thing. All right, so now creating linear regression models. So you may have done this before in your previous math classes, but it wants us to use a graphing utility to draw a scatter plot, then create the line of best fit to analyze the data in the table. And so on the next few pages here, is the instructions for your TI-84, or if you had a TI Inspire, I think I also included the instructions on that. All right, so they gave us a table here, and so what we're going to do, it kind of walks us through it. Let me pull that up. All right, so for your TI-84, the first thing you're going to do is clear your calculator. So go ahead and clear it. And then you're going to make a scatter plot of the data points. So you're going to go to Stat, and number 1 says Edit. And in Stat Edit, you're going to put your X's in L1 and your Y's in L2. So on the previous page, we had that table, and these were the X's that were in it. They actually had years, though, and these were the Y values that matched up to them, okay? So we started out with 2006, but it tells us here that we're going to let 1 equal 2006. So this was 2006, this was 2007, 2008, and goes all the way to the 7 was what? 2012, was year 7, okay? So we're going to type in 1 through 7 in L1 and all the Y values in L2. Make sure when you get to the end that they end in the same row. Once you get your numbers put into your calculator, then you're going to go activate your scatter plot. You're going to go to second stat plot, which is your Y equals button, and choose plot 1. You need to make sure you turn it on. Verify that the X's are where it says X list says L1, and where it says Y list it says L2. Doesn't matter which mark you pick. So make sure it's on and make sure those are correct. Then to view the scatter plot, you're just going to go to Zoom, and you're going to hit number 9, which is Zoom Stat. And so doing that will set our window so that we can see all of the points that we put in there. So we put this into our Stat Edit. We turned our stat plot on, and then we hit Zoom Stat to get our graph down there. Now to find the line of best fit, we're going to go back to Stat, and we're going to arrow over to Calc. Now this one had told us in the directions here, it said that we wanted to write the linear regression for the model for the price of oranges in dollars per box. All right, so I want the linear. So you're going to go Stat, Calc, and you'll see number 4 says Lin Reg. That's linear regression, so you're going to choose it. Just verify that it shows your X's are in L1, your Y's are in L2, and then you're going to need to add this in there. This is where your calculator will store that regression equation so that you don't have to retype it. And so we're going to put a Y1 there. Now, it tells us right here how to get to that Y1, okay? So Y1 comes from, you're going to click the VARS button, which is right next to the clear, kind of below the down arrow. You're going to hit the arrow over to where it says YVARS. You're going to choose function and then choose Y1. Make sure it says Y1 there, and then go down and hit enter on calculate. And so it's going to give you your equation. It's going to look like this. It's going to tell you Y equals AX plus B. That's how you know it's linear. And it tells you what your A value is and what your B value is. So we know that our equation is Y equals 0.357X plus 10.389. If you want to see how well that fits your data, then because we pasted it, we put it into that, under the store regression equation, we put Y1, we pasted it into our Y equals, so you can just hit graph. And then you will see the picture they have down here. Then if you want to calculate future prices, you can't calculate anything that's not in your window, okay? So like if I want to look at down here, it says what is the expected price per box for 2014? This is when my T will equal 9. So I need to go to my window and make sure that I can see at least 9. So go ahead and change your X max to 11. And then you can go through, you can hit the trace button, up arrow, and then just type in the number that you're after. So if you change your X max to 11, then go to trace, up arrow, and then it'll say like X equals, you type in 9, and it's going to give you the Y value there. And it should tell you $13 and about 60 cents. And then for 2015, you're going to do the same thing. This is when t is equal to 10. So you're going to go to trace, up arrow, and then type in 10. Hit enter, and it'll tell you that your Y value is $13.96. All right, and then it has the instructions for TI Inspire. So if you have one of those, you can use it. I don't have one, so I can't tell you anything about it. But if you need help, come see me. We'll figure it out together. All right, then example 3, the quadratic models. So the table below shows the height in inches of transmission fluid that is being drained from a large storage tank. So we have the time and we have the height. It says model the data with a quadratic function. So we're going to put this in our calculator so we can find that quadratic function. So we're going to go to Stat Edit. Your time is your x's, so put them in L1. Put your height in L2. And then we're going to run regression. All right, so pause the video if you need to while you do that. So once you get all your numbers in, you're going to go back to your stat. You're going to go over to calc, and you'll see one that says quad reg. Okay, that's quadratic regression. So choose it. And we want to go ahead and paste this into our, we want to go ahead and paste this into our stat edit. So make sure you change that store regression equation. Make sure you put the Y1 in there if it's not already. Now, we did not look at our data. If you want to look at what it looks like ahead of time, remember, go to Zoom and hit 9 as long as your plot is turned on. Okay, so Zoom 9. You can see it. If you haven't, we'll do it in a minute. Anyway, so let's run the regression since we're already there. And so what we can see is it tells us y equals ax squared plus bx plus c, and it tells us what a, b, and c are. So we're going to come up with our regression equation. So our height at time t, and this is an estimated, so I'll put the little hat there, equals 0.00774 x squared. And then b is negative 2.082 x. And then our c is a positive 123.119. Now, if we want to see how well that fits the data, go ahead and hit your Zoom 9 so that you can look at it. If your plot was on, if your plot's not on, you're not going to see it, so you need to follow those steps again to look at it. All right, it should fit the data pretty well. B says we're going to use the model to estimate the height of the transmission fluid in the tank at 35 seconds. So this is when t is equal to 35. So I'm looking for h of 35. And so if you're looking at your graph, remember you can hit trace. Well, first though, we got to make sure your window covers at least 35. If your x maximum's not past 35, it's not going to show it. So go to your window, check your x max. If it's not at 35 or bigger, change it to something. So change it to like, I don't know, 40. And then hit trace, your up button, type in 35. And it's going to tell you approximately 59.723. This is the height, and it's measured in inches. So you need to label it. How long will it take to drain the storage tank? Well, I want to know how long will it be until the height is 0. Okay, it's empty. There is no height to it. So some different ways to do this. Probably can't use your table because it's not going to help you. Remember, though, when the equation is set equal to 0, that's where it says 0. So we could go to second, trace, and choose the one that says 0. And then we'll have to do our left bound and our right bound. Another way to do this is just setting our equation equal to 0. And so I'm going to come back up here to A. And so it's the same thing if I put this equation's equal to 0. I could go put this in my y1. 0, which is already there, 0 in my y2, and go find their intersection. Either way we do this, we should find that our time is at approximately 87.743, and it's times that's measured in seconds. All right, and that is the end of part A.